Okay, so it's a pleasure to be here. Worcester is actually my home, and I did spend a couple of years at Worcester College, and I met my wife here, so it's a special place for me. So I'm going to kind of introduce the topic, and I'm going to introduce it by telling you a story. So this is not a lecture. You're glad there's no PowerPoints, no quizzes, but we're really interested in your kind of ideas about understanding the science behind this, because I think it's a really serious contemporary problem that we ought to be talking about and doing more about. So that's kind of why I'm here. And this is kind of the first time we've done this, so we'll kind of make it up as we go to a certain extent. So again, it's a pleasure for me being here. So for me, as Jeff said, I got a strange background. I go through life as an epidemiologist and somebody who's very interested in emerging infectious diseases and diseases of animals and people, and how that all comes together, and that's what we're going to call the perfect microbial storm. Right? So to kind of talk about that, we'll kind of push the pause button and go back 10 years. So I can remember very vividly waking up one morning because of my bias in my life and found out we had 3 diseases in the United States, right? West Nile virus. How many have heard of West Nile? You all heard of West Nile, right? We had cases in Wooster. There was another disease called SARS. Anybody remember SARS? Right? Severe acute respiratory syndrome. And another one I bet. How many remember monkeypox? Wow. I forgot OARDC's here. So I woke up in the morning and we had those 3 diseases. And so what's the big deal about those? Well, a couple of things. None of them had ever been in the Western Hemisphere in the history of the world. They all showed up here at the same time, right? And they all had another thing in common. They all had their origin in animals. So as we kind of probe this tonight and think about this, what is going on in our world, right? It has created this kind of conditions where these diseases are spreading around the world. And why is this story then interesting? Because you're going to hear a lot more about this. Okay? So what about West Nile virus? So it's a virus that was in Africa, a little bit in the Middle East. It came into the middle of New York City in 1999. The hottest summer, by the way, in the history of New York City. So we dropped a little virus particle in the middle of New York City with 8 million people that were all susceptible. And oh, by the way, they had mosquitoes, lots of them, and that's how this disease is transmitted. And they had birds. And birds is how it's maintained in nature. Right? And so it was just the right conditions. When it was first found, it was misdiagnosed because we hadn't seen it before. And the person that actually found it was a pathologist, a veterinarian in the Bronx Zoo, who had a bunch of birds dying and didn't understand why. And once we found out what that virus was, then that it had come into the United States, people didn't know what to think. There wasn't a vaccine. And they thought, well, we'll just kind of stop in New York City. Well, here we are in 2013. Last year was the second worst year of cases of West Nile in the history of the United States. And we've had about 2 million human cases of West Nile since that little particle of virus entered New York City, across the United States in every state, and now it's spreading into South America. So that's kind of one story. And by the way, there's 34 species of mosquitoes that can transmit it and 134 species of birds in which can be infected. And when it leaves this bird cycle with mosquitoes, it infects people and horses. And I can remember living in Michigan at that time, going for a walk with my dog, and crows literally falling out of the trees. Because they're very susceptible along with blue jays, and robins are probably the biggest maintenance. So people, thought, wow, this is something pretty unique. And then SARS came along, right? So what about SARS? So we've never seen it before. It's called a coronavirus. We fortunately have experts here in coronavirology. But it entered into the United States in a little different pathway, right? And there were cases that started, and it was in southern China. And so people started getting ill, and we didn't know quite why. And once the illness was kind of understood as a coronavirus, unique, not had been in human species before, right? we did kind of the backward trace and said, well, how did that happen? Well, it actually happened in a market in southern China. So in China, people will go and get fresh animals every day as part of their meals. So you go in and you pick out an animal, and they're kind of killed as part of that market. They're called wet animal markets, right? And so you got reptiles and birds and all kind of animals and people and blood, and it's all kind of mixed. This isn't very good about dinner time, is it? It's really, you know, a special kind of opportunity. And what happened is that from animals, this came into people, all right? And once a person got infected, there were some strange things happening called super spreaders that were able to infect lots of people. And in a short few weeks, right, they had 8,000 cases, 800 deaths, and it went to 37 countries. Pretty amazing. And when we went back and looked into that market, right, there was an animal called a civet cat. And the civet cat is actually an animal raised for food in China, and tested that animal and had this very exact coronavirus that infected the person, and everybody thought, well, that's what happened, that's where that virus came from. And I won't tell you how many civet cats got killed to try to stop that, you know, to eradicate that. But what we found out as we went a little bit further was it actually has a reservoir and a bat, a horseshoe bat that was also a food source in that market, and the bats don't get sick. So it went from that bat to these civet cats, amplified into people, and got transmitted because the disease didn't show up very quickly in some people, and when they actually went into different countries, it was because of our airport system that just spread all over the world. And then we had monkeypox, right? It's a orthopox virus. You see it in Africa. We see it in West Africa. And by the way, it's on the increase. And it came out of a little girl that got bit by a prairie dog in Milwaukee, Wisconsin. So here's this little girl, and when she got bit, she actually had pox. So, and the pox really looked like a disease called smallpox, which we have eliminated from the world. It's the first really pathogen that we've ever eradicated from the face of the earth. The second one is rinderpest, so in case the New York Times has that in there. Got it? And so this pox looked like smallpox, and people got very excited because of where did this come from, and was this a way of actually bioterrorism? Did somebody actually throw this virus in to start an epidemic on purpose? So when we looked at this little girl and we went back, she actually ended up having exposure for the prairie dog that was exposed to an animal called a Gambian pouch rat. Now, I don't know why people don't buy cats and dogs anymore, but we have different kind of pets. The Gambian pouch rat came from West Africa, right? Had the pox, went into an importer in Texas, got mixed up with a bunch of animals, including prairie dogs, went into Milwaukee into a swap meet where people traded all kinds of reptiles and animals back and forth to each other. The prairie dog got infected, went home, bit the child. The child got infected, we had 71 human cases. So this is just a little story to engage you to say, why did all this happen? And is it going to continue? And my answer is, it's going to continue and it's going to accelerate. And the reason is that our world is remarkably interconnected. So how many people on the face of the earth? 7.2 billion, right? Last year, the world produced 40 billion food animals. Billion. To feed these people, right? We have all the wildlife, we have our own pets. We throw products in there into a wonderful kind of worldwide food system where foods are imported and exported worldwide. We have a transportation system where 1.6 billion people cross international borders every year. 1.6 billion. So it's a world in constant motion, moving all the time. So we have this 21st century mixing bowl. Animals, products, people, bugs, mosquitoes, right? And we put them in a whole different environment where our world is changing, completely connected, and what are we doing? We're changing the environment, we're changing kind of the landmass, we're worried about climate change, and all of these are going to change the conditions of these diseases. So 30 years ago till today, 75% of all new human infections come from animals. 75%. So what is the connection then in terms of animal health and human health? You can see how it's all now kind of playing together. So this is the great convergence, and the microbial storm then is all the conditions that have been created that will enable these new emerging diseases to come up in animals and in people, and by the way, in plants. And it affects plants as well, whether they're bananas or coffee, which we just learned about yesterday, that impacts the food supply, that impacts human health as well. So our world is interconnected in these special kinds of ways. And they've created what we call wicked problems. A wicked problem is really a business term. And they're problems that don't have yes or no answers. And old solutions really don't solve them. And it requires a different kind of discipline and different kind of people to come together to understand these problems and to create new solutions. And so that's why you have great researchers at OARDC and wonderful professors in the College of Wooster and people in this community who are gathered around, also worried about this and doing work to help understand it and to create new solutions. And those new solutions are going to come out of what we call One Health. So animal health and human health and environmental health are all connected. Our lives are connected. These diseases are connected that way. And we now have to study them and do research and do interventions based on our understanding of working in all three of those at the same time in an integrated way. So it's a whole different strategy in health. It's a whole different strategy in what's going on and what is going on globally. So it's because of the pressure we're putting on these animals and the disruptions, and then the technology that we have is spreading them worldwide, right? And then our own behavior. We take vacations in spatial ecosystems. We have food imported from all over the world. So we've created the perfect conditions for this storm, and it is accelerating. So we talk about a human-animal interface. So right now, if you think about that interface, in eastern United States, including right here, right, there are more animals and more people and more trees than any place in the world at any time in human history. Look out your backyard. So it is this mixture then of our animals and people with this human-animal interface that is becoming very interesting to us in terms of kind of health conditions. So what else is happening? Antimicrobial resistance. So these bugs are really good. They're winning, right? They adapt, they change, they move around the world faster than their incubation period, and we're giving them wonderful opportunities to jump from one species to another to people. And that's what we're seeing. So where do you think influenza comes from? It comes from your neighbor, but it originates in animals, right? It probably originates in birds and ducks and pigs and in the right environment with people, and that's where the next epidemic is actually brewing. And so that connection with our animal world becomes hugely important as we move together.